Hello everybody, welcome to part 2 of solving the problem substring with concatenation of all words. In the last video, which I just created, we basically solved the next problem from LeetCode Stop Interview 150 problem list real time. And that problem was substring with concatenation of all words. And in that video, we basically, did what we always do. I took the problem, we understood the problem, read it, figured out an approach, we implemented the approach, and we submitted it. And after we submitted it, we noticed that it only beats like about 12% of all the submissions in time, and which is okay. Like, I'm not going to be able to always create the best code that is the fastest of all the submissions. But having said that, while we were implementing that approach, I noticed that there is a slightly different approach we could take, which could, at least I got some hunch. I couldn't really put my intuitive finger on it. If you saw my video, you will know what I mean. I was very confused in how to explain it, but I did get a hunch that things could be done slightly differently, and it could actually be better in some inputs. I still do not know if that modification will actually help us improve our time efficiency, at least meaningfully. But I thought I'll create part 2 where we'll try to do that and compare and contrast the approach with our approach that we have already implemented and see if it actually helps us improve the time efficiency. So while I'm not going to go through the details of the problem again, because you should watch the last video if you don't already know the problem. The video is called Substring with Concatenation of All Words Part 1. I will very quickly summarize the problem, as it will also help my chain of thought, and you will get a very quick review yourself as well. Well, the problem is we are given a string S and we are given a list of words. Actually, let's look at example 3 because that's the one we took here, and a modification of that also is what we used to come up with the approach, but at least this is what we took mainly. We are given a string S and we are given a list of words. In this case, the list contains 3 words, or the array contains 3 words. And we are supposed to find out all start indices in S which contain a concatenated substring of these 3 words in any order. So for example, in this case, there are 6 different ways to order 3 words. Bar foo the foo bar the foo the bar, and so on and so forth, right? And we are supposed to find out if any of them exists in S and at what start indices. So in this specific case, this particular substring starting at index 6 has the 3 words concatenated in some order. Then at starting at 9, it has the 3 words concatenated in some order, and then at index starting 12 it has the 3 words concatenated in some order. That's why we are supposed to create a list 6, 9, 12 and return it. And so the approach we took was actually, in the end, it turned out to be quite straightforward conceptually, at least, that we said, okay, hey, if there are 3 words here, each of the words is length 3, then the substring we are looking for in S has to be of length 9, because all of those words have to be concatenated with each other exactly once, right? By the way, duplicates are allowed in the words array, but still they have to be appended exactly once. And so the substrings we are looking for are of length 9. So why not look at all the substrings in S of length 9 and see if it is a valid concatenation of all the words in the words array. So that is what we were exemplifying here by this particular comments here, which is, hey, all the substrings of S which are of length 9, well, they are starting from 0 ending at 8 inclusive, starting at 1, starting at 2, and so on, and the last start index is 15 because the otherwise, the substring goes out of the bounds, right? So anyway, so those are all the substrings, and for each of them, let's just evaluate: is it true or false? Is this a valid concatenation? Is this a valid concatenation? Is a valid concatenation, and so on. And the way we did that, which is given a specific string, whether it is a valid concatenation of all the words, Actually, it looks like we modified the words array to actually kind of demonstrate that. But anyway, so the way we did that is we actually created a word frequency map using a hash table, which is we looked at all the words in the words array and we put it in a frequency map. Like a bar occurs once in the words array, foo occurs twice, and the occurs once. And then we basically peeled off words of size 3 from that substring of length 9, and we checked if that word existed, and if it did, then we would decrement the count of that and so on, and ultimately if we find all of them exactly once, we say that is a good start index which contains a valid concatenated string. So that's the approach we took, and we implemented that and we submitted it. Well, in the end, this is what I was writing, and then I realized the video was becoming too long. I was also not able to explain properly intuitively what I was thinking about. But I think what I was trying to, so let me attempt it again, right? Where does this approach potentially become inefficient? So imagine that, so actually this is the approach I was describing which would remove that inefficiency. So let me do the following. Instead of making this comments, changing these comments, let me actually go down and copy, because I'm going to anyway implement a separate helper for the second approach. So let's do that here. Okay, so let's take this example. Let's take this example and let's say the words array contains bar, foo, the. Okay, so foo occurs twice. Okay, and let's say that it's like this. Actually, let me do the following. Let me just remove this bar for now because that's not relevant for what I'm trying to explain. Okay, so in this case, our approach is, okay, hey, let's take start index 1, right? At start index 1, what is the substring of length 12? Foo, bar, right? That is the sub. Okay, for that string, let's peel off the first 3 characters. We say, okay, hey, first 3 characters are foo. Are we allowed foo? Yeah, we are allowed foo. So we say, okay, so we say foo. Are we allowed 2 foos? Yeah, we are allowed. I mean, we added the second foo and that's what we are allowed. And we'll check this using the word map. So, but that's not important for what I'm trying to explain. Are we allowed the third foo? Well, no, we are not allowed the third foo. And we will just return false. That, hey, this is not a valid thing. And then what we'll do is we'll actually go to the next substring. We say here we return false. Right? We say we return false. So far we were good. Here we were good. Here we were good. Right? But now we just go to start. Oh, sorry. This is not start index 1. This is start index 0. My bad. And now we say, okay, start index 0 didn't work out. Let's just go to start index 1. And we reset our entire word frequency map, right? The word frequency map which started with, hey, bar should occur once, foo should occur twice, and the should occur once. And we reset. And some point after considering start index 1, start index 2, we will come at considering start index 3. And at that point, if you think about it, what we are going to check is we are going to check this, right? Because that is, if you think about it, this is the one substring of length 12 that starts at 3. But we reset the whole word frequency map. If we went from 0 to 3 directly, what we could have done is instead of returning false, we say, okay, hey, in third foo instance is not allowed. Okay, so I'm not going to append that. So let me now actually take 3 here, right? So 3 is now not a separate thing. What we are going to do is we are going to say, we are going to start index 0 and we are going to consider the whole string starting from 0, right? Not just the string of length 12. So we are going to consider the whole string anyway. But when we start at 0, what is the first thing we add? We say, hey, is foo allowed? Yes, foo is allowed. Word map has foo is allowed twice, so we can allow it. Then 2 foos are allowed. Yes, that's good. Oh, this is not good. So actually at this point, we should actually, this is not good, which means let me just put a dot where, we actually moved the dot, right? So the dot was here. So 3 foos are not allowed, but we are not going to remove the whole word map. We are just going to say, okay, let me try to peel off from the left side, from here. Keep peeling off the words until I remove a foo. So here we can actually remove this foo. and now this becomes our start word, and now we can add the second foo, right? So we move our dot to there, and if we do that, we'll actually end up finding this one very quickly, right? Much more quickly than if we reset the whole map. So we basically have three uh, groups that we need to consider: start index 0, start index 1, and start index 2. And the reason is the start index 3 would already be covered by the group 0, right? By this algorithm of, uh, have a string and try to keep appending words of length 3. And whenever you cannot append a word, you start peeling off from the left side, actually. If that word was valid, but it was just an additional instance. Now, of course, if the word is completely not valid, which means imagine if the word was like, uh, at, at this point, you got foo foo and not third foo, but you just got XYZ. At this point, you don't have to peel off from the left side because this is not even a valid word. That is never going to be actually allowed. So you can just start from after XYZ, right? Like you can just discard everything here, right? And say, okay, hey, before XYZ, nothing, like we can't really do it. And after that, maybe there is more stuff. So that's kind of the approach that I think, at least in a bunch of input cases, might run faster than just dumbly going from 0 start index to 1 to 2 to 3 to 4 and so on. So, okay, so I'm going to try to implement that approach. I think here, the one thing I want to figure out before I actually implement that approach is how do we kind of do this in code. So let's think about that a little bit. I think the left and right concept of that is needed. So let's say again, this is our string and we are at start index 0. Okay. So we say, hey, our start is equal to 0 and current equal to 0. And when current is where we read a substring of size 3 from current index, right? So what is the substring of size 3 from current index? Well, 0, 3, right? This is not Java syntax, just my notation of saying, hey, starting at 0, size 3 substring is foo. And is that something we can add to our, to a valid concatenation? And yes, we can, because remember, our words array allows us to foo. So we say, okay, so here our actually, what we do is we say current equal to 3, right? We just move current. Logically, we append it. So start comma current is our substring that we are considering, right? So we say current equal to 3. So we moved it forward, right? So that means now here we say start equal to 0 and current equal to 3, which means the substring we are looking at, we already have is foo. Here the substring we already had was empty because it was started at 0 and ended at 0, right? So maybe I should call this left and right, not start and 0, left and right, because I think that makes more sense. So let me call this left and right. So the string we already have is foo, and what we now want to add is we say s dot substring of starting at index 3 and 3 more characters, and that is another foo. And we say, oh, that allowed? Yes, that's allowed. So we keep our left alone because remember that indicates our left side of the whole concatenated string. But we increment our right to 6, and that indicates that this string is so far good, right? It could be potentially lead to a valid concatenation. And which means now we say 6 starting at 6 and length 3. Hey, what is that? We have another foo there. And this is where we say, oh, that's not allowed. And if that is not allowed, and then we start to peel off from the left side a word, and we peel off by moving left by 3, right? And right is still 6. We haven't been able to append the word at index 6. So, and that's why we basically reduce our string to the second foo, this foo here, right? And now we say, we still do the same thing, right? 6, 3. Is that allowed? And we say, oh, second foo is allowed. Yeah, sure. That's actually foo. And that is now allowed because we peeled off another foo from the beginning. And that's where we keep the left the same, but now we move the right to 9. Right. I think this is the approach. I wanted to, it's the same thing that I discussed here, but sometimes this translation is needed in our head before we start coding. Otherwise, we just get lost in coding. So I think this actually really makes me comfortable to start coding. Okay. So before I do that, let me just make this a private. I'm just going to copy this signature and make this private because I'm going to make it a helper find substring 1, right? Because we are implementing find substring 2. Okay, and then this is the public that is still needed. And here we are just going to return find the substring 2, which we'll implement. We haven't implemented yet. And okay, so now our job is to implement find substring 2. Actually, let me just do this. Okay. Okay, there. Okay, so now here what do we do? So first is, well, this happens for a specific start index 0. Remember that. And we are repeating that for 0, 1, 2, and so on based on the length of the word, right? So we need that kind of a loop here. But before that, we still need the usual hash map, which is a word frequency map and other things, right? So let's get that in order first. So we say int word count equal to words dot length, int word length equal to words of 0 dot length, and then int substring length equal to word count times word length. Okay, and now what do? We say, oh, we also need the hash map of string comma integer. Actually, you know what, I should probably just copy a few lines from here. Yeah, I think I should do that. Okay, there. So we still build the hash map, right? But now we run a loop with various start indices. Start index equal to 0. Start index is less than word length. Remember that, right? If the word is full 4 long, then we have 4 start indices where we need to run that algorithm we just talked about. Plus start index. Okay, and what do we run? Well, we're going to call some helper. So let's call it find substring at index, right? And we'll pass it s, we'll pass it start index. That's where it starts everything from. As before, let's pass word count and word length, although it could itself find out how many word count and word length, but we'll pass them because we have them. And then we say word map and results, right? The results, because there could be multiple results this helper could find, which it needs to add to results, right? Okay, and then say return results. Okay, so the core of the whole algorithm is going to be in this function. Okay, so what all is it getting passed? Well, it's getting passed a string s, start index, word count, word length, and then let me just make more space here. Word length, then word map. So hash map of string comma integer word map, and then list of integer results, right? So those are everything that it needs, and this is the function we are implementing. Okay, so let's see. So here this is what we are actually implementing here, right? Literally. So let's say our left is equal to start index. Right initially still starts at start index, right? Like we discussed here. Left is 0, right is 0. And that means our concatenated string so far is defined by left comma right inclusive, right? The indices. Okay, so those are our left and right. And what are we doing? Well, we are saying, oh, we need a new hash map of string comma integer, because we don't want to destroy the original one, right? So let's just do equal to new hash map word map. We are going to copy it, right? like just like before, and we'll decrement the count, right? So in this case, I think we can also increment the count and start from 0 and increment the count and compare to the word map, right? So we could also do that. We don't have to, I mean, both will work, but I think building up would also work. So I'm going to try to implement that to see if it works. Okay. And then we just have our while loop where left plus, well, we actually need substring length, right? So one second, we could have passed that as well. Word count times word length, left plus substring length minus 1 is less than s dot length, right? We have to be within bounds. I think we may have to check the right is in bounds as well. Does right change independently of left? Yeah, it does actually. So I think we have to check that too. Right plus word length minus 1 is less than s dot length. Because remember, starting from right, we are going to look up word length number of characters from s, right? So that has to be less than the length. Okay, less than s dot length. So that is our condition. And what is the thing we are doing? So we already have a concatenated string, and we are trying to append to it one more word, which we read from s. So let's say a word equals, right, s dot substring right comma right plus word length. That is what we are doing, right? And yeah, that is the word from s that we are going to check whether we can add that word or not. First, we need to find out whether how many occurrences of that word are desired, right? So let's say string, not string, sorry, integer desired count equals, well, desired count is always in word map. We never touch it, and we kind of treat it immutable. So we are going to look up the word's frequency by word as the key, and 0 is the, actually let's do this, integer 0 as the default value if it doesn't exist, right? And we also have to see how many times we have already seen this word, right? So we say found count or something, and found count is, actually let's call this found map. Already found, right? Already found words map of that. Found map dot get or default word, still the same default, same key. So we are finding the same word in the already found map and saying, hey, I want to add that word, but I want to see how many occurrences of that word are already found before, right? And we have to now, yeah, this is where we get kind of interesting, right? So found count is less than desired count. Actually, I think we should do dot int value here. I don't know what Java does with capital I integer classes when we do like mathematical operators like that. So if the found count of this word is lower than the desired count, lower than, like in our example, foo could exist twice, but it's not found twice yet, and we found a foo here, then in that case it's the happy case, right? We just add this word, which means, and we are not literally adding it, we are just adding it by incrementing the right index by the word length, which means we added the word, but we have to update the map, found map, right? So found map dot put word is the key, found count plus 1, right? So that's what we do. Else, okay, so else has two cases, right? Else means this could be greater or equal to, right? The found count is greater or equal to, well, it won't be greater because we will prevent it from becoming greater. But let's say else is found count is equal, right? So which means found count equal desired count. Okay, in that case we actually have two cases. The two cases are that they are 0, found count is 0 and desired count is 0, which means this is a completely different word than we want. This is not a word in the word map, right? So we say if desired count actually, desired count dot int value equal 0. In that case, this is a word that we don't want. This is the case where I think, did we cover that case here? Yeah, XYZ, right? XYZ case. And we can just set our left equal to right plus word length, right? Left is completely reset. We can reset the found map dot clear. So we reset all of them to 0 because we are starting from scratch. We are going to make our concatenated string empty again, right? And right equal to left, right? That is how we indicate that we are empty, right? Okay. Is that all? Found map? Yeah, I think so. We cleared the map. Okay, so that's that case where this is an undesired word completely. But the else case is it's a desired word, but occurred an extra time, right? Then we want it. In that case is where our efficient approach is now going to kick in. We are going to peel off one word on the left side, like here, and add, not add, but we are going to adjust the found map accordingly, right? So, okay, so what is the left word? So let's say string left word equals s dot substring left comma left plus word length, right? What is going on? I'm not typing very well today. Okay, and we will basically decrement the count of that, right? So integer, well, I mean, we can just assume it exists. So we say, because otherwise we have a bug in our code, right? We say found map dot put found map dot get left word, sorry, here also left word and found. Actually, I think if I write in one line, it's going to be confusing. So I am going to write it in 2 lines. Left word count equals found map dot get left word. Sorry, this video became long, but this is not an easy code to write real time. And yeah, there's lots of places we have to be super careful. So left word count -1, right? Because we are going to remove that left word, and that's why we did this, right? Okay, and then we say left plus equals word length. That means we removed one word from the left, we adjusted its count in the found map, and we still haven't appended, right? We'll just go back and check. Maybe we need to remove one more word and one more word until the count of this word goes lower than the desired word, right? So I think, okay, so those are the 2 cases there. And this is why I think it will never become greater too, because of our logic. We are not going to let it become greater, right? Okay. So that's that. 1 second, let me see. Okay, but when do we find out that we actually made it? Like we found a valid concatenation. So that happens here. Okay, but we need to, okay. So whenever we add a new word to the concatenated string, we need to check whether we found everything, right? And for that, I think we need one more variable actually, which is the number of words which have been added to the concatenated string. So let's say int num words added equal to 0. Initially, we don't have any words we have added to the concatenated string. If we are doing this, then we will update that plus num words added, right? And here is where we check if num words added equal to word count, which means we've added all the words, and whether we added appropriate words is already checked by the logic that we wrote so far. This is where we found a valid start index, right? So it's a results dot add left. Okay. Yeah, I think that is all. But we do need to adjust the numwords added as well everywhere. So here, if we clear it, we are going to do equal to 0, right? And then if we peel off a word, we are going to do minus minus, correct? Yeah, I think so. Okay, that's a lot of code with a lot of logic. I don't know. I'm going to try to run it. I think overall it should work, but I'm pretty sure there might be compiler errors and a couple of other errors in the desired logic we want to implement versus what we ended up doing. So we'll see. We'll have to fix that one by one. Okay, integer left word count. Oh, left word does not exist. Oh, that's because, okay, that's easy. Let's fix that. Okay, left word count doesn't exist. Okay, let's fix that. What is going on? Okay, today my shift pressing skills are not good. I think a lot of the capitals that I wanted capitals are lowercase. Oh, cool. Okay, so it did work for all of them, which is actually something I was not expecting. I was expecting some logical errors as well. Okay, maybe it paid off to be so conscientious when we were implementing step by step. Let's try to submit this approach. The video has already become too long. I'm seeing about 31 minutes, but hopefully it was worth it. All this, and if it still beats only 12 to 15%, then I will have to think about why it is so low. Oh, cool. Okay, so this is amazing. I'm so happy. 97% it is beating because of that optimization, right? I'm really happy. I think a lot of the examples in this one that it probably tests against, I don't know if there is a way to easily see that, probably have a very long array of words. And this trick is probably helping when it is just, like I said, in this case, the foo, just because of one extra instance of foo, you don't have to reset the whole thing. You can actually still keep the most of the word frequency map and it works. Okay, hopefully that was helpful to you guys. I'm really glad I spent the time in kind of, implementing the improved approach. And yeah, if you're liking what I'm doing on this channel, please consider subscribing to my channel. It really encourages me to make more of such content. And please hit the thumbs up button on the video. See you guys next time.